In the previous video, we covered the PKT cap user world tool. In this video, we will look at managing the SNMP support that's provided in the vSphere 6.x environment. First, we'll look at the basics of SNMP, explain the various terminology like MIBs and OIDs. We will then speak a little bit about how SNMP can be of benefit in troubleshooting situations. We will then see how SNMP can actually be implemented and configured in ESXi 6.x. We'll go through the detailed process of obtaining and importing VMware MIBs and then the OIDs, and we will then see how we can obtain information from the ESXi hypervisor using a test tool and then a full-blown network management platform as well. I think you will enjoy these labs. So before we jump into the SNMP lab, let's make sure that we understand what SNMP means, what MIBs are, and how OIDs work. To facilitate this, I'm at the website of Paisler.com and I'm looking at their knowledge base. Now the reason I'm looking at the Paisler website is because I use their network monitor, which we will see in the lab. But let's just pay some attention to the overview of SNMP, MIBs, and OIDs. So SNMP stands for Simple Network Management Protocol. It has three key components. You have the managed device, you have the agents, and then you have the network management system, the NMS. So in our case, the managed device would be the ESXi host. The agent would be the SNMP agent that will be running inside that host and enabled. And then you have the network management system. Now there are many network management systems out there. The one that I'm going to use to demonstrate would be the PRTG network monitor that is marketed by Paisler.com. Of course, because SNMP is a standard protocol, it's based on RFC 1157, which was the initial SNMP version 1. It works over many different protocols like UDP, IP, CLNS, AppleTalk, and IPX. Of course, IPX is novel and AppleTalk is also defunct right now. But although this knowledge base talks about SNMP version 1, one of the difficulties with version 1 was that it was insecure. It was actually developed at the dawn of the internet age, and security was not so much of a concern. It was more important to understand exactly what was happening out on the internet. Since then, there have been version 2, version 2C, and version 3. Version 2C and version 3 are secure protocols or relatively secure protocols, and it's recommended that one use them in a production environment. In our situation, we will use SNMP version 1 because the objective of this course is to show you how to enable the SNMP agent on the managed device, which is ESXi. There will be two other terms we will use. One is the MIB, which is the management information base. So SNMP provides the protocol, and then the format of the content is provided in the management information base, so that using SNMP, one can monitor any network device as long as there is a MIB associated with it. So who creates the MIB? Well, usually the MIB is created by the vendor. So for example, if Hewlett-Packard has manufactured a printer, Hewlett-Packard will create a MIB for that printer, for all the parts of the printer and the various things in that printer that one would want to monitor using SNMP. So the standard protocol of SNMP is basically this. SNMP sends out a request from the network management system, and the managed devices return a response. Now this is very similar to HTTP. Of course, SNMP predates HTTP by probably about 10 years or so. And there are four operations: get, get next, set, and trap. We won't go into too many details here, but obviously get would mean get a certain value, and then get next would be get the next one. Set would be obviously to actually set a value of a certain item, and trap would be if there are any issues with something that's being monitored to send a message to the network management system using the trap consists of the enterprise agent, agent address, the trap type, trap code, timestamp, object value. So it's basically something that's an issue. And the information, the SNMP messages consist of a header and a protocol data unit, a PDU. Again, a PDU is it's a pretty old term from the OSI days, but doesn't matter. The key is we need an SNMP version number, just like in HTTP we need the version number, and then we need a community name, which is a very simplified way of acting as sort of a password, but it really doesn't do anything very much because it's out there in just text format. It's not encrypted in any way. So basically the MIB is created by the vendors. For example, with ESXi version 6, there's a whole set of MIBs which define what can be monitored within ESXi hosts that have been created by VMware. And we'll go through the process to show you how exactly one would take a MIB from VMware and then make use of it. The object identifiers, or the OIDs, are uniquely identified objects in a MIB hierarchy. So basically it's a tree, okay? And in the tree, the nodes are assigned by different organizations, okay? So it's a long sequence of numbers separated by dots. And the top level MIBs belong to different ISO organizations. And then vendors define their own private branches for their own products, which is what VMware and Cisco and HP and every vendor that has a MIB for their product actually uses. So in a different part of the Pestler.com website, we learn that there are monitoring programs like the PRTG network monitor that I will be showing you and I'll be using in our lab. We learned that the MIB stands for Management Information Base, and it's a collection of information organized like this. And the OID stands for an object identifier, and they uniquely identify managed objects in a MIB hierarchy. So a sample. Let's look at this sample here. We have the ISO organization. So ISO org.department of defense.internet. And what you'll see is that every MIB basically starts with 1361. So 1361. They all have numbers. And then, of course, private, and then you can have different aspects of it available. So example, this would be an OID. And of course, you don't have to learn what all this means, because there are object browsers that actually do all the translations for you based on MIBs. So just very clearly, these numbers are the ones that are used in network management systems, network monitoring systems, such as the one that we'll be looking at. When you set up sensors in order to access the appropriate elements of the device that you want to monitor. So remember, the MIB is created by the vendor, and then it is loaded into the network management system. Once it's loaded into the network management system, the network management system now knows how to handle that managed object. And with that, we are going to just take a look at a couple of other items here. So before we jump into the lab and look at other parts of how all this would be set up, this is www.pestler.com, and the product that I'll be using is the PRTG product. It's a network monitoring tool. I am not associated in any way with Pestler, but I do use their product in my lab, and I encourage you to take a look at this. We will be looking at basically 3 items. They are generic to most network management systems. One is the network management system itself. Then you have the ability to import MIBs, and then you have the ability to have actually a browser working on MIBs. So you have an object browser for MIBs. Obviously, the exact implementation differs from vendor to vendor. I'll be showing you the version that I have from Pestler. So I'll be showing you the network management tool. I'll show you how to import MIBs, VMware ESXi 6.0 MIBs into the product using the Pestler tool for importing MIBs. And then there is a MIB object browser that's available as well that I'll be showing you. So one of the first things we need to do is to find the SNMP MIB modules for ESXi version 6. So I would recommend that you look at 10134445 in the VMware knowledge base. This is the article that has the information that you require. It's very new. It's been updated September 8th, 2016, and you are able to download the MIB here. It is attached. So one of the things I did before I actually set anything up in my lab was to download this set of MIBs. So I downloaded the MIBs and I unzipped them. And that is what I would recommend that you do first. So I downloaded the VMware ESXi 6.0 MIBs, and when I unzipped them, it created a folder with basically the same name. So I have version 6.20 MIBs, and in this folder, these are the various items that were available. So you can see they all have a .mib suffix, and the bridge is obviously for the software bridge, which is the distributed switch or the switch. Then you have again the bridge MIBs. The Q would be probably for the 802.1 Q VLAN, and then you have the lags, link aggregation groups. This is basically for interfaces, INET addresses. IP forwarding would be router based, obviously information about routers. Here we have LLDPs and so on. ARMON, SNMP v2, that's version 2, and so on. There's a whole bunch, and then there are these specific VMware MIBs. The VIB is the virtual infrastructure bundle, which is a totally different thing. So this is the MIB, management information base. So this is the set of MIBs that is available from VMware when you download and unzip. Now what do we do with this? How do you actually make these MIBs available to your network management system? So in the case of Passler, and that's the case for most of them, there is a process and it's specific to every vendor. But in this case, there is a Passler MIB importer, and that's what we will take a look at next. So having downloaded the VIBs from VMware and then unzipping them, I then went to the Passler MIB importer, and this is a separate product from the network management system. And I click on File, and it gives me the ability to import a MIB file. And what I did was I basically selected all of them, the ones that I had unzipped, and then pressed the open button here, and that loaded and imported all the VMware NIBs into the system, and that is what we see here. So let's take a look at some of these. I will start like this. Let's take a look at the bridge MIB. So that's 802.1 D base. There's not much to see here, but the key here is the host resources MIB. So you have the HR storage, the HR storage index. So you see the OID here, and a description, which is a unique value for each logical storage area contained by the host. You can take a look at, for example, if you look at the storage description, if you click on this, then that's the OID to get that managed object, and it's a description of the type and instance of the storage described by this entry. We can take a look at link aggregation group. So we look at these. The descriptions are not there for this, but anyway, the idea here is that after you download the MIBs and you unzip the MIBs, there is a way of importing the MIBs into the network management system, and that's basically what I have done here. It is now available if I configure the network management system to start using this library. Okay, and this is obviously some kind of an object browser as well. So you can click on these, and these are all standard MIBs, basically number of user sessions and so on, and we'll see how these are used very shortly. Okay, so we've downloaded the MIBs, we've unzipped it, and we've imported them so that they are now in an OID format in an OID library. So after they were made available into the OID library, what I then did was to use another Passler product, which is the SNMP tester, just to make sure that I had everything working correctly. Now, in order to make this actually work, what I have to do is first to make sure that the ESXi host SNMP configuration has been completed, and that is something which I have not done yet. So before we look at testing out SNMP, which is what I have done here, let's take a look at the changes I had to make into the ESXi host to make all this work. So I'm going to log into my ESXi host first. So I secured shelled in here, and I'm logging in. Okay, I've logged in now. ESX CLI system SNMP, and the various available commands after that are get, hash, set, and test. So let's just do a get first to see how the SNMP is configured right now. So this is how SNMP has been configured. The communities are public, SNMP is enabled, the log level is information level, the ports, it's basically 161 and 162 are the two standard ports used by SNMP, and the target is 192.168.0.76, which is basically my networking system host at 162. That will be the port, and the public is the public community. Notice this is a SNMP version 1 configuration because I have not set any v3 targets. Now, how did we actually get here? How did I set all this up? What I want to do is to first show you how it all works, and then at the end I will go in through the exact process of the steps you have to follow to set up SNMP on a ESXi 6.x host, essentially to get what we have here. And the reason I want to do it is because there are many more options around SNMP version 3 that I want to show you, but I don't want to jeopardize and have to redo things because everything is working quite well at this point in time. Okay, so we found the MIBs from VMware, we unzipped them, and then we imported them so that they are available. And we are now in the process of looking at to see how we can verify that SNMP from the ESXi host, which is 192.168.0.211 is actually working. Prior to this, I showed you briefly the configuration that I had set up on the ESXi host, and we'll get to that in more detail. But essentially, one had to enable the SNMP agent on the host and set up some firewall rules to allow traffic to proceed on ports 161 and 162. We'll get to that in a later part of this video. So let's see what we have up here. So my local IP address, which is the management address, is 192.168.0.76. The ESXi host 211 is this, and I'm going to look at port 161. And the SNMP version is version 1. That's all I have enabled right now. The other two options are SNMP version 2C and version 3, and these are more secure options that are available. But again, you have to configure a few extra things. The community was public, as we saw earlier. So what am I going to do here? I am going to scan the OID library. So if you recall, I had imported the MIBs, and the MIBs were imported and processed. They were scanned and processed into an OID, an object identifier library. And that object identifier library is right here. It's something which I called vSphere 6 when I actually did the importer using the Passler MIB importer. To cancel that, and all I have to do right now is to start the test. So you can see what's happening now is that this SNMP tester is sending SNMP gets and probably get nexts as well to the ESXi host, and it's scanning through the OID and getting information back from the ESXi host for every managed object that it has in its OID. Now, if you recall, there were quite a few management information bases there, MIBs. So there's a lot of information that is being sent back. And if you just give it a couple of seconds, we will be able to take a look at this. And here we are. It has retrieved those values for the managed objects for all of them that we had specified in the MIBs and then translated into the OID. Let's see if we can find something that is readable. Okay, so this looks like plugins. Let's look at some host resources, LACP. Let's find some disks. Here we are. So let's take a look at some of these here. So what you have here, as you can see, is information returned from the ESXi host 211, something about /vmfs/volumes and so on. So these are basically the volumes that are available on that host, and this is the information. So this is the storage description. So it's OIDs 1.3.6.1.2.1.25.2.3.1.3 and then .1 and then .2, .3, .4, so on. So that's the information there. This information is the allocation units, okay, for each one of those devices. Okay, so here it is. This is 4096 bytes, 64K, 8K. So these are the blocks, resource allocations, right? These are the storage used, okay, amount of storage used on those volumes, and storage allocation failures. The value is 0 on all of them, looks like, so nothing much happened there. So this is how it actually works. Now, of course, this is very raw information. It is an SNMP tester just to verify that things are actually coming back correctly. Now, of course, this is exactly the way the network management system would work as well, except that it has a lot more intelligence in it. So after this, we're going to move to we're going to just look at one more custom ID. So here is a custom ID here. Let's start that. And you can see it went out to device 192.168.0.211 from my network management system using SNMP version 1. The OID it was looking for, the object identifier was this, and what it actually returns back to you is the value of VMware ESXi, which tells you basically the host type that's out there, and it is an octet string. ASN is or ASN 1.1 is the abstract syntax notation language that is used to specify MIBs and so on. It's kind of used right now, but there are different ways of specifying now using YAML and various other languages. But anyway, this is what ASN stands for. So here we are. So this specific OID actually translates to the value of VMware ESXi. So in this case, this SNMP tester, just like a network management system would do, also actually goes out there to the SNMP agent and then retrieves this value from the ESXi host. Let's now take a look at the network management system. So I'm now here at the PRTG network monitor, and this is just to give you an idea of what is possible. Of course, VMware's product vRealize Operations Management also gives you this information and is very specific to VMware. I just wanted to give you a different flavor of it. So essentially what happened in this case was that it went out when I set it up initially and discovered just about everything that there was here. Okay, so what it discovered is the various VMware hosts. So this product understands VMware quite well and understands Hyper-V as well, as you can see here, quite well, understands VMware vCenter servers too. Because what it did was it went out there and found everything. So for example, on this host ESXi 211, the one we looked at briefly and where we have SNMP running, right? You see that this ESXi host has 2 warnings and 10 other sensors. Sensors are basically things that are looked at, values of items that are looked at to make sure they are in the green or in the warning zone or in the red zone. Okay, so data store free information is there. The vCenter, which is running in there as a virtual machine. If I just hold my cursor on it and hover on it, it gives me information about that vCenter. So this is everything that it's set up. The various ways it's looking at it right now is with pings and HTTPS as probes. It is also, interestingly enough, checking for on port 443, and it's giving me a warning. And we'll look at later what this warning is. It really is telling me that I have low level of, I believe it's TLS, transport level security. I believe it is TLS 1.0 still enabled up here, and I really should change that. So to get this, I had to do nothing. I just had to start up this monitor and let it do its thing. Now, where does SNMP come in? So how is it doing its thing right now? How is it getting all this information right now? So let's go into ESXi 211 and see what we find here. So when I clicked on ESXi 211, this is the screen that showed up. So it's basically pinging there, and it says everything is okay based on CPU usage of 4.56% and normal states and so on. But let's look at the various sensors. It has 12 sensors. Ping, HTTPS, different other types of pings, checking the host performance, hardware status, data store, and these are the virtual machines that are on that host. Now, let's see. So how did it find this information? Click on host performance. When I click on host performance, you see that it's saying that the sensor type here is VMware host performance SOAP. So it's using the vSphere SOAP XML APIs to actually access the VMware host and obtain information. The point I want to make is this, that there are many ways to get to this information. You can use the SNMP protocol. You can use the XML APIs that are there as well. You can use other different methods. There's also something called CIM that can be used to monitor hardware details. As you can see, the information is very detailed. This is the kind of performance graph that one gets from the performance graphs on vCenter, and actually in all likelihood, since this is using the APIs, that is exactly the way it's done in vCenter performance graphs as well, which is why this graph looks so familiar. So looking at the overview for this, you can see that automatically, and remember, I did not do anything, I just set up this network management system, and this is quite similar to what other network management systems do as well. It went out on a voyage of discovery and found all this information for me and set everything up based on the smarts, the knowledge that it has of the kind of things I'm likely to be looking at. As you can see, it has all the kind of stuff that one would normally be actually looking for. So going back to the screen for ESXi device 211 right here, we learned that the information from provided here in these sensors, these 12 sensors, essentially was done using pings, HTTPS, and using the vSphere APIs. But what about SNMP? So in this product, what I did was I clicked recommend now, and when I clicked recommend now, it went through a whole entire analysis and came back and said, look, I think you need to add these sensors as well. As you can see, these sensors are 2 additional sensors of CPU load and uptime, and there are disk-free sensors that are based on SNMP. So it's saying add 10 more of these. So what is this? PRTG can inspect your devices to recommend useful sensor types. It recommends that you add these sensors to get a much better and more detailed picture about the status of this device. So I will click this and add a sensor. So these sensors are now being created. Some of these sensors are based on SNMP, and they will show up in a few moments. Took about 20 seconds, and then these new sensors came up again. Remember, we had 12 sensors before, and then it added these 10 other sensors. So from 12 plus 10, so now we have 22 sensors. So CPU load, disk free, and it is gathering information right now slowly. So this will populate as it goes through its process. Let's click on CPU load, and you can see the sensor type here is SNMP based. So this information is coming using the coming to this network management system using SNMP for the protocol, which means that there is an SNMP agent running on that ESXi host. To go back to the overview, these are the processor sensors and so on here. Let's look at devices. The disk-free sensor, as you can see, they have now populated, so the information is now available about the disk free. Let's look at this one. This has free space of 36%. I click on that, and again you can see that this was based on SNMP, so it's again using the SNMP protocol and not the other way we saw earlier, which was the vSphere APIs. And this is the information that's available. You have the free bytes, the free space, downtime, the total size, and everything else that one could possibly need. In every network management system, it kind of works in this way. The exact process is always a little bit different, and you can set what it means to be in the red or in the green or in the orange because these values are all customizable. So you can see that SNMP is a very powerful protocol, and especially the fact that it is a internet standard. So any network management system worthy of its name will actually be able to make use of managed information bases, MIBs, MIBs, the OIDs, the object identifiers, using the SNMP network management protocol that we just saw. We're going to shift gears a little bit and go back into the ESXi host 211, which we have just seen here, which is actually sending out information to this agent using the SNMP protocol, and see how SNMP is configured on an ESXi host. So we're back again, logged in into that ESXi host, and we had entered this command ESXCLI system SNMP get to just show you what is configured. A public community was configured, and the target, which is the network management system that we were looking at, has. So it's using port 162, and that's the standard format that's used in here in the public community. So how is this actually configured? So let's look at ESXCLI system SNMP and see what the various options are. Well, there is an option to set. Okay, so SNMP set. Now, when I hit the enter key, it says specify what to set or dash dash help. I wish some of these commands had more consistent help. When I see dash dash help, I really need to pipe it to more because there are many options available. Okay, so this is how one sets up the ESX SNMP agent. There is an authentication. So if you're going to use authentication, MD5 SHA1, again applicable more for SNMP version 2 C and for version 3. We don't use authentication here in version 1, which I've shown you. You can set up communities. We did set up a community. We set up a community of public. We do have to enable and disable, which means start and stop the services. For SNMP version 3, you need to have engine IDs. I don't have to worry about this for SNMP version 1. You can specify where the hardware information actually comes from when you get a get from SNMP. So get to SNMP, and then whether you use the IPMI sensors or the CIM indications. So which is actually quite interesting. I really should try it out because I have IPMI sensors available on my host. I will check that later. With CIM and IPMI either being available to retrieve information for your network management system is really terrific. Okay, this is more about large stores and so on. The log levels are important. So to what level are we logging? So info, warning, error, or debugs. Here we have traps, so we can set the traps to be sent to the network management system. The UDP port poll the SNMP agent on, and if you recall, we used 161 in our SNMP tester. Let me just quickly bring it up here. Here we are. It's port 161 is what we were using, and which is why we have this. So let me move this back. Okay, so we are polling properly on 161. Didn't have to worry about remote users and so on because we're using basically version 1. It's not really needed. This is a very useful one. People don't tend to use it. This reset to reset the configuration, but it's good practice to actually reset this when you are setting up your SNMP agent or making changes to it. Reset it and just enter everything one by one. Okay, and click again. Targets. This is what we had set up. So we had set up targets. So it was 192.168.0.211 at 162, and it's using UDP, and then the community was /public. So that's how that is actually set up. We can try out some of these commands. As I said before, it's good to reset the configuration. So ESX, CLI, system, SNMP, and we basically have to do a set-r would reset it. So now it's reset. Now we disable it. So set and then -e or -- enabled -e, and then we specify. So now SNMP has been disabled. What we do now is to set the communities, which are set by -communities, and then we were using the public community. It is actually community. I missed the -- for communities. We then set the targets. It's -- targets 192.168.0. So 0.76 with network management system at 162, and the public community that's been set. We then enable it. So we set E to true. So that is enabled. It's good practice again to do a /etc, start up the daemon again, .d, and then we have the SNMP daemon, restart. Okay, so that's running, and then the ESX CLI command to system SNMP, and then we do a test of this. Says first enable the SNMP agent. So set E true, test, and it says there is one target configured, send warm start requested, test has been completed normally. So the the ESXi host agent is now talking to the agent on the network management side, which we had set up at 192.168.0.76. So everything is working. This is the target that we set up, if you recall. So it's talking to that target, and everything is working. So we have the managed host, we have the agent in the managed host, and we have the configuration that's been set up on the network management side as well. Now, just very quickly, the process is actually different in different network management systems, but there's always a place where one has to configure user ID passwords or credentials or certificates or something in order to be able to access the ESXi hosts, or for that matter any of those managed systems that one is looking to manage using SNMP. So please be aware of that. You need to have an understanding of how access is provided to those devices, because the devices can be anything ranging from Cisco routers to refrigerators to ESXi hosts. So apart from setting up the SNMP agent on the ESXi host, we also have to make sure that these ports 162 and 161, which are used by SNMP, are actually opened up in the firewall. So we hit clear, and ESX CLI network firewall rule set list, and going through this by piping it to more, we see that the SNMP rule rules are actually enabled. And the way this is done is it's reasonably straightforward. The commands are, again, it's ESX CLI network firewall rule set, and then we need to set the name of the rule set we just saw is SNMP. So we need to set the rule set SNMP. The keyword is rule set ID, and then allowed all, which means all IP addresses is true. Already allowed all IP. That's the way I had it set up. And then we need to enable that rule set. So rule set ID, instead of dash dash allowed all, we will say enabled is true, and that's basically enabled. So what this allows us to do is, and of course one would probably do a restart of the SNMP daemon by basically keying in slash init.d slash snmpd restart, something on these lines, and that would kind of restart itself appropriately. So that's how it has to be set up. Just a quick point here. After restarting the daemon, you will see that there is a message that might come up which says that the daemon has been disabled and that you have to enable it again. And that's what I see here. When I keyed in ESX CLI system SNMP get, I saw that it was not actually enabled. So one has to enable the SNMP daemon again. So just be on the lookout for this. When you restart the daemon, just make sure that message doesn't show up, or if it does, then this is what you need to do, is to enable the SNMP daemon again. And so with that, we come to the end of our course on advanced aspects of vSphere 6.x. We hope you enjoyed viewing this course, and I would like to thank you on my behalf. I'm Atindra Chaturvedi, and also on behalf of Pact Publishing. I wish you the very best in your career.